Hello everyone, welcome to this new session in your module Big Data and Business Analytics. In that session, we are going to introduce the concept of artificial intelligence and machine learning. Here you have the learning objectives for that session. The first one is to understand what predictive analytics is. Later, you will learn the key features of artificial intelligence and machine learning, and we will explore different techniques and good practices to apply machine learning algorithms. Also, you will understand what are the potential and limitations of artificial intelligence and machine learning in a business context. Well, first of all, I would like to contextualize the concept of artificial intelligence. AI is everywhere. This is in our phones, car, shopping experience, romantic matchmaking, hospitals, banks, and all over the media. Nowadays, managers, team leaders, investors, and policymakers are anxiously racing to learn about artificial intelligence because they all realize it is about to fundamentally change their businesses. Basically, artificial intelligence over time learns to better manage performance and respond more accurately to user needs. But like the human brain, artificial intelligence can't yield immediate benefits just by being integrated. Its task is to recognize images, voices, and languages and process them as data. This means that this device can, at least in theory, make decisions and optimize performance based on what they have learned from use. So obviously, artificial intelligence and machine learning are in things like predicting whether a particular person will develop an illness or whether they'll recover from an illness, whether a particular person is likely to pay off a mortgage or loan, or whether an investment will pay off for you, and even very common things like building a recommendation engine to suggest other things that people can buy when they are shopping online, etc. All of them are hugely influential areas and major consumers of predictive analytics methods. But what is predictive analysis? Basically, this is a general approach for trying to use data to predict what's going to happen. The process is to find and use relevant past data. It doesn't have to be really old, it can be data from yesterday. But you always have to use data in the past because that's the only data that you can get. Then we will have to build a model to predict the outcome using any of many possible choices. And finally, you take that model and you apply it to new data to see what's going on in there. So the main three steps in predictive analysis is to find and use relevant past data, to build a model that will predict outcomes, and apply this model to new data in order to get predictions for this new data. So it is clear that prediction is a key concept for the current artificial intelligence. And I would like to differentiate two meanings of the word prediction when we talk about predictive analytics. One of them is obviously about predict future events, which means to use data that we have currently available to predict something that will happen later in the future. On the other hand, the second meaning that we can give for prediction in predictive analysis is to provide an approximation to how a human would perform a particular task. By making predictions, the algorithms will try to accurately estimate what will happen in that case. A classical example is about classifying photos. In that case, you are not trying to look into the future, but you are trying to say if a person were to do this, what would they do? There are a few categories of methods for doing predictive analysis. Number one is classification methods. That includes things like key nearest neighborhoods or nearest centered classification, and also is connected to clustering methods such as key means. We will cover some of these methods in our next session in Python. You can also use decision trees and random forests, which is several decision trees put together, as a way of tracking the most influential data in determining where a particular case is going to end up. And then, also extremely powerful in data science are neural networks, a form of machine learning that has proven to be immensely adaptive and powerful, although very hard sometimes to follow exactly what's going on in there. So all of these methods have been very useful within trying to predict what's going to happen with a particular case. Well, before contextualizing artificial intelligence, I would like to give some context to the concept of intelligence, to the concept of human intelligence. Here you can see that human intelligence involves learning, conceptualization, logical reasoning, pattern recognition, planning, problem solving, decision making, etc. But even more importantly, the human intelligence includes external and internal reflection, decision reversal, paradigm shifts, motivation and persuasion of other humans, ability to resolve contradictory information, creativity, spontaneity, emotions, and definitely this second group represents a much bigger challenge when we try to simulate this intelligence in a machine. We can define artificial intelligence as the ability of a machine to perform complex tasks which normally require human intelligence and decision making reasoning. We can see that the ability of machines has been extended to design, planning, learning, decision support, pattern recognition, and similar complex tasks. But to make that achievements will require not only a great computing power, but also a solid base and understanding of concepts from information communication theory and cognitive psychology. So what are the signs of intelligence for machine? Maybe some of you are familiar with the Turing test. Alan Turing was one of the pioneers of computing, and around 1950 he designed a simple quiz. If a reader could not reliably distinguish whether the answers came from a human or a machine, then the machine passes the test for intelligence. In 1956, in an important workshop that took place in the USA, the participants proposed that each aspect of human learning and intelligence could be so precisely described that a machine could be programmed to imitate it. So basically, they were providing an initial definition for artificial intelligence. Another classical example to understand differences and similarities between human intelligence and artificial intelligence is the Chinese room. Basically, this experiment argues that there is no essential difference between human mind and an appropriate programmed machine. But the main problem, the main difference, is that the machine lacks understanding or intentionality as we, human beings, understand it. So we can accept that the human brain is a machine, but the human brain would be a qualitatively different type of machine because the human brain has consciousness. So basically, all this resonance has stimulated an interesting debate in the literature in both philosophy and cognitive psychology about artificial intelligence. So the question is, what's the current state? What's the current level of artificial intelligence nowadays? And maybe the first key insight is that this new wave of artificial intelligence does not actually bring us intelligence, but instead a critical component of intelligence, which is prediction. I suppose that you know this device, Alexa. You can ask something to Alexa and probably this device will give you the right answer. But what Alexa is doing when you ask a question is taking the sounds, processing that sounds and predict the words you spoke and then predict what information the words were looking for. So if we are asking Alexa about what's the capital of the UK, Alexa doesn't know the capital of the UK, but Alexa is able to predict that when people ask such a question, what's the capital of the UK, they are looking for a specific response, which is London. Now I would like to provide some conceptualization about machine learning. Machine learning falls within the broader topic of artificial intelligence. Nowadays, it's probably the liveliest area in artificial intelligence. And basically, the machine learning algorithms allow computers to learn new things without being programmed specifically for that. So, as a definition, we can take that machine learning is an application of artificial intelligence that provides the system of the ability to learn automatically and improve from experience by feeding data and information. Currently, machine learning is focused on the development of computer programs that can access to data and use this data to learn from themselves. And the main question around machine learning is, how do machines learn? Well, we can distinguish three main methods for machine learning. The first one is supervised learning. We apply supervised learning when we know enough about our data. So we can help our machine connect the dots with supervised learning. In supervised learning, you show the machine the connections between different variables and known outcomes. In machine learning, this is called the labeled sample data and the correct output. It's called labeled data because it's already tagged with identifying information. So an example of supervised learning would be if we want to know how long will it take to drive home, based on data from weather, time of the day, and if we are on holidays or not. So the first step would be to create a set of labeled data. This data would include weather conditions, time of the day, and whether it's a holiday. These are your inputs. The output would be the amount of time it took to drive home on a particular day. The first thing that you want to do is to create a training set. And based on this training set, your machine might see there is a direct relationship between the amount of rain and the time it takes to get home. The more it rains, the longer you will be on the road. The algorithm might also see that there is a connection between the time you leave work and the time you will be on the road. The closer you are to 5 p.m., the longer it takes. So the machine will find some relationships with this labeled data. So the model begins to understand concepts like how rains impact the way people drive, or that there are more people who travel during certain times of the day, around 5 p.m. Later, the machine will take these training sets and apply it to a test set of our data. And it looks to see if the model in the training sets holds true when you are looking at different data. You can also give feedback on how accurate it was in its prediction. and over time the machine will learn and adapt its model to improve the output. Unsupervised learning might seem the most familiar. If you think about it, many actions that we learn are acquired through study and observation. So basically by learning and improving by trial and error. So learning and improving by trial and error is the key to unsupervised learning. In that case, we are not working with labeled data. We are not showing the machine the correct answer. Instead, we are using different algorithms to let the machine create connection by studying and observing the data. Normally, the first thing that unsupervised learning do is to classify, and this is called multi-class classification. In unsupervised learning, the machines will study the data and will come up with its own observation. So they can cluster the data, but they can also use techniques to create connections or even find something new. This type of learning is used in many industries. For example, drug companies are using this technique to try and find chemicals that might behave like an antibiotic. And the third way in which machine can learn is the semi-supervised learning. This is a crossover that takes advantages of both supervised and unsupervised learning. Imagine, for example, that you want to create a program that could translate voicemail into text. It would be difficult to use unsupervised learning here because your machine will cluster words together but wouldn't necessarily know what those words mean. So your program doesn't know that a sound for a specific word is the same thing as the word. On the flip side, you wouldn't want to use supervised learning. It would be very labor intensive to label all the data for words and their sounds. Plus, you could never create a training set that was large enough to translate all your possible words and phrases. So instead, you might try here semi-supervised learning. So you will start with a smaller training set of very common words and phrases. The machine could use this to perform some basic classification. But then you will feed that training set into the machine and allow it to study and observe the rest of the data. With the labeled data, the program could use a form of inductive reasoning. But in semi-supervised learning, we have another type of learning called transductive reasoning. This allows you to narrow down the unlabeled data by thinking about what you already know about the collection. What this kind of reasoning does is to improve the model by making better guesses about what's in the unlabeled data. Semi-supervised learning is not such common, but it works well in certain areas, particularly in areas where for the machine it's not so difficult to create useful groups, but at the same time the data is so large that it's not practical to use supervised learning. The important thing is to understand that semi-supervised learning really only makes sense when the other two approaches have difficulty solving your challenge. Because you need to keep in mind that inductive and transductive reasoning might lead to greater errors and mislabeled data. So before explaining neural network, it's important that you understand a little bit about cognitive psychology. In 1949 was developed the idea of unsupervised learning based on statistical cluster of certain types of interneural messages in which neurons learn to connect more strongly with selected other neurons based on previous experience. Later, the idea or perceptron was developed. This is a binary mechanism whereby a neuron made a connection according to whether a neuron or message was or wasn't of a particular type. In 1986 was published the process on how artificial neural networks can be used for learning. So to put the model into practice, we need to provide inputs of experience, a set of discrete processing units, an output function, a set of connection between the different units represented by direction and strength, time-dependent functions to activate the unit, a rule for propagation, an activation rule, and even more important, a learning rule for modifying the connection weights. So here you have the classical model for feed-forward artificial neural network. We have the input, the hidden layers, and finally the output. In the feedforward network, information only moves from input to output. In order for learning to take place, the actual output is compared with some desired output. If there is a difference, an algorithm adjusts the weight of the connection to try and produce a more accurate output. Through this process, the network learns to produce the correct output. Alternatively, the outputs can be compared with other outputs to see if it is better or worse in order to arrive at an optimum output. From machine learning, we arrive to the concept of deep learning, which arises from the development of more complex networks. Deep learning involves multi-layer networks and recursive or repeating connections which could allow the network to learn with inbuilt algorithms and to deal with unstructured inputs of variable size or nature. This involves learning the features involved in the raw data input and allows the network to structure input data in a way which is amenable to processing such as data from speech or images to see if it is better or worse in order to arrive at an optimum output. Due to the depth of the network, this usually takes longer time than a shallow neural network, thereby resulting in a time-consuming training processes. Here you have some key aspects to consider in machine learning and for deep learning in particular. We will continue talking about these concepts and to implement some practice next week. This is all from me now. Thank you for listening. Goodbye.